Okay, Assalamualaikum everyone. Alright, today we will cover we continue with the chapter functions and graph. So basically last week you have covered two subtopic, relations and functions, and the other one is composite functions. And so this week we will cover another two more subtopics, which is inverse functions and exponential function. Alright. Okay. So what is inverse function? Let's look at the definition. So if you have a fx to y is a function that maps x to y, then the inverse function is denoted by y equals to f inverse x, where y equals to f inverse x is a function that maps y back to x. Okay, let's look at the diagram below. So x to y is f, y to x is the f inverse. Okay, please take note that f inverse is not equals to 1 over fx. Okay, it's different, right? So if we look at here, domain of f, right? Domain of f is equals to range of the f inverse, right? Range of f is equals to domain of the f inverse. Okay, terbalik, right? So an inverse function of f exists only if the function f is one-to-one function. Okay, always remember that inverse function only exists for one-to-one function. Right? Okay, there are a few methods to test whether a function is one-to-one. Alright, one-to-one. The first one is algebraic approach. So if fx1 equals to fx2, then x1 equals to x2. Okay, second one is by using horizontal line test, which is a graphical approach. Okay, graphical approach. If the horizontal line intersect the graph of the function only once, right, then the function is 1 to 1. Okay, so for example, you have a green line, that green line of a graph, then that red color is the horizontal line y equals to k, for example. So the horizontal line intersect the graph at one point only. Okay, second example, if you have a quadratic graph and then you write a horizontal line y equals to k. Okay, there are 2 points of intersection, so we say that this is not one-to-one function. So if the graph is not one-to-one function, meaning that there is not inverse. Okay, the first one, the graph of A is one-to-one function, so we can say that there is inverse for that function. Okay, let's look at the example. Show that the following function are one-to-one function. Okay, the first one, A, fx equals to 3x minus 2, where the domain x is R. Okay, so we use the first method by algebraic approach. So if we have fx1 equals to fx2, we start with this expression. For this method, we always start with this expression, and then we substitute this equation. Your general equation is 3x minus 2. Okay, but then what the difference is, you change the left hand side become x2, because here your domain is x1, so here is x1. If here is x2, then x2. If you are using x3, let's say you want to change f x2 equals to f x3, then you have to show that x2 equals to x3 also, can, no problem. Okay, and then this one we can simplify that 3, so we say that x1 equals to x2, so we prove this method. Okay, meaning that we can conclude that fx equals to fx is one-to-one function. All right, if you're using second method, okay, so this is a straight line, kan? We are using the same equation, y equals to 3x minus 2, where the domain is all real number. Okay, so if you are using this horizontal line test, so you will draw a horizontal line y equals to k. K is any number. Okay, k is an integer. Ataupun dia boleh juga menjadi decimal. K is R, suppose K is R, because this horizontal line you can test here. It can be here Y equals to K, ataupun somewhere here Y equals to K. Asalkan, as long as it is a constant number, right? It's a horizontal. In this case, they are using this pink line, kan? So there are only one point of intersection. So we can say that this function fx is one-to-one function, right? For b, the equation is x cubed plus 7, where x is r, okay, and then we show that, okay, fx1 equals to fx2 to show that x1 equals to x2. Then you just substitute x1 power 3 plus 7. So plus 7, we can remove, we can eliminate. Then we left only x1 cube equals to x2 cube. Then we cubic root for both sides, then you get x1 equals to x2. So we say that gx also is one-to-one function. So when they are one-to-one function, meaning that that function have an inverse, alright? Okay, method 2 also the same. So this is the function. So we sketch that horizontal line y equals to k. There is only one point of intersection. Okay, then we say that this function fx, gx, right? Tadi soalan gx is a one-to-one function. Okay, that is how we prove that that function is one-to-one function. Okay, now we look at how to find the inverse function. Okay, so number one is using formula f composite function. Yeah, this one f inverse x equals to x. Right. Number two is by using substitution. Okay, please take note that f inverse and one more time inverse outside equals to f. Number two is f inverse fx equals to x also equals to f inverse x equals to x. It's the same. Okay, composite function of fg negative 1 inverse is equals to g inverse composite with f inverse. All right. Okay, let's look at the example. Given fx equals to 4 over x minus 1, find the f inverse. Okay, the first one, we are using the formula f inverse equals to x, then 4 over f inverse x minus 1. Okay, now in this case, your x is become f negative 1x. Suppose this one got x here. Right? So when your x is f inverse x, so here we'll be changing to f negative 1x as well. So you have this. Okay, and then we rearrange everything to left f inverse itself on the left hand side. Okay, then you have this 4 plus 3x over x, where x cannot be 0, right? Okay, next example, example number 2, fx equals to 3x plus 5. Find f inverse and square, and the other one is the other way around. You find the f2 first, then you find the inverse. Okay, this question is to show you that the answer for both will be equal. Okay, so f inverse x equals to y. So this is another formula to find the f inverse. We let f inverse equals to x, f inverse x equals to y, then f y equals to x. Then now use the formula here, given function fx equals to 3x plus 5. Now your x become y, so it will be 3y plus 5 equals to x. Since here you already let that your y is equals to the inverse of f, so we have to make sure this y become itself alone at the left hand side. So we bring everything to the right hand side. So you will get the, after you have y equals to x minus 5 over 3, since you already let from the first part here, okay? Okay, you just change lah, y equals to f inverse x. So y equals to f inverse x equals to x minus 5 over 3. Okay, then this f inverse So f inverse -1, f inverse in bracket x minus 5/3, and we substitute inside here kan. So x minus 5/3 minus 5 over another 3, right? So you will get x minus 20/9. Okay, same thing for number B. Okay, same thing for number B. F square x equals to f3x plus 5. Okay, and then we put it inside 3x plus 5. This one should be plus 5, should be here, plus 5. And then we multiply inside, so you will have 9x plus 15 plus 5 is 20. Alright, so this is the f2x kan. So by using this f2x, then you find the inverse. Okay, you are using this formula also can, ataupun you can also use the formula tadi tu yang f inverse equals to x also can, no problem, it's the same. Okay, so we want to prove that uh, f inverse composite with another f inverse is also equals to f, and you find the inverse is the same. Okay, so these are the exercise. Okay, so you try do by yourself. During class later, we discuss which question you don't know how to do. Alright, so this one, please take note that composite of f g inverse is equals to g inverse f inverse, right? Okay, now this is the important part. I think this is the new for you, how we find the graph of the inverse. Okay, the graph of an inverse function can be obtained by reflecting the graph. Okay, reflecting the graph about line x equals to y, ataupun yang you biasa is y equals to x, is the same. Alright. Okay, please take note that domain of f is equals to range of the inverse. Range of the f is equals to domain of the inverse. Okay, you remember from the earlier slide just now. Okay, let's look at the example. Sketch the graph of f and f inverse on the same axis. Find the domain and range of f and f inverse if given fx equals to 3x plus 2, where x is real number. Okay, so this is the domain kan? We can write here domain of f is equals to x r. This is also range for the inverse kan tadi. Take note lah, dia terbalik. Okay, so this is the solution. So use the formula to find the f inverse, then you get x minus 2/3. Okay, domain is a negative infinity to positive infinity, which is also, this is also r. Okay, ataupun kita panggil sebagai r, real number, this one, from negative infinity to negative infinity. Kalau, if you remember, if you can imagine, 3x plus 2 is a straight line kan? If your domain is a real number, meaning that your range also will be real number. Okay, so that's why lah dia directly can write here, dia punya range will be negative infinity to plus infinity. Okay, so for inverse, domain of f is their range kan? Range of f is their domain. Okay, so this is your f. Okay, fx equals to 3x plus 2. They're passing through at y-intersect 2 here. Okay, oh ada tulis itu. And then just now by definition, the graph of inverse is where you reflecting your f across y equals to x. So this is the graph of y equals to x, meaning that, okay, can you see it is reflecting across y equals to x, so that is your f inverse. Okay, this is your f inverse. Okay, very easy, you just reflect across y equals to x. So if in exam we ask you to sketch a graph of f and F inverse on the same axis, you have to sketch that line y equals to x. That one is 1 mark. Okay, it is very important because by definition it is reflection of F across y equals to x. Okay. Okay, this one very easy. So if this is the coordinate of 0 2, reflection will be 2 0. Okay, very easy. And then they will meet at one point at the line of y equals to x here. Okay, let's look at more example. For each of the following function below, find the inverse function and state the domain and range. Sketch the graph on the same axis. Okay, let's look at the first one. Okay, fx equals to negative x squared plus 5 x greater than or equals to 0. Why they put like this? Because remember, in order for a function to have an inverse, okay, that function must be one-to-one function. One-to-one function meaning that you cannot have 2 point of intersection when you test with the horizontal line. Okay, if for example the domain here I just put x in real number, so if you sketch this graph, then what will happen? Okay, it will touch at 5, so a is negative 1. So if a is negative 1, meaning that your graph will be set like that. Okay, so if this is 5, meaning that your graph will be like this, can? So if I test fx, if I test with a domain of x real number, meaning that this is the domain, can? This is your x, so all line here, and then we test with the horizontal. Okay, this is my horizontal line, y equals to k, so there are 2 point of intersection. Okay, so if 2 point of intersection exists here, meaning that it is not one-to-one. So that's why this question is rephrased dengan with a new condition here, that we just consider for domain x greater than or equals to 0, meaning that we just consider this domain, this one here. Okay, so this part we don't consider anymore. So when you test with the horizontal line, there is only 1 point of intersection. So if 1 point of intersection, then only inverse of this fx will exist. Okay, clear, kan? Okay, for this one, alright, so that is your graph of f. Okay, we test with horizontal line, there is only 1 point of intersection. Okay, so meaning that it have an inverse, right? Okay, second one, we find the inverse function. F inverse x equals to 5 set of 5 minus x. Alright, okay, so domain of f is 0 to positive infinity, meaning that this is dia punya range of inverse. Okay, range for f is domain of f. Okay, so before we look at the graph, let's look how they find this function. Okay, let's say I'm using the formula let f inverse x equals to y, then fy equals to x. So now I have negative y squared plus 5 equals to x. I want to have y alone. So negative y squared I bring to this side. So basically I have y squared equals to 5 minus x. Okay, so y equals to plus minus set 5 minus x. Here you have to answer plus and minus. So since, okay, you look at the domain given from your f. Okay, so since this is greater than 0, it's positive, so meaning that we will choose y equals to positive 5 minus x set. So therefore our f inverse x is set 5 minus x. Okay, clear, kan? Alright, so back to our graph. So this is our graph tadi, our f. So this is the line of y equals to x. Okay, Okay, you see at the pink line, a pink graph, that is our F inverse, right? So if we look at here, okay, if we refer to the blue graph, right? So the blue graph, can I change my pen color? Pointer option, in color, okay, let's say I'm choosing blue. Okay, so this blue is my function f, yeah. So this is my domain kan, this is my domain of f equals to 0 to plus infinity. Okay, but then uh, 0, this is the also the range of f inverse, kan. How is it? If you look at here, the pink color, okay, if I change the pointer again, pointer option in color, pink, okay, let's say I'm using red lah. This one kan, this is the range, okay, range of f inverse, ini. Nampak ni, your graph is starting from here and this is going this side kan. So this is basically our range of f inverse. Okay, so that's why this is equals to 0 plus infinity. Okay, how about the range of the domain? Okay, I change back my pen to blue first. Right, in color blue. Okay, so in this case, this is my range, kan, going down. So my range of f is equals to negative infinity up until 5 because it's going down. Okay, how about the inverse? In color, red color. How about the inverse? Inverse, dia punya range will be negative. Range of f is the domain kan, domain here will be the domain, meaning that here, this one, this is they are equal with the domain. So domain of f inverse is negative infinity up to 5. Okay, that's how we look at the graph lah. Right, sorry, this one is f inverse. Okay, b hx set of x minus 2, x greater than or equals to 2. So this is the inverse function x squared plus 2. Okay, very easy. Domain of h also equals to range of h inverse. Range of h equals to domain of h inverse. Okay, so if we look at here, this is our graph of h, and then we draw the line of y equals to x. Okay, and then we just reflect with the across y equals to x. That's it. That is the h inverse, right? Okay, how about this one? C, 2 over x minus 3, x greater than 3. So in this case, our fx cannot be touching this line, kan? Meaning that x cannot be 3. Okay, there will be an asymptote line. You cannot touch at that line. Okay, and then you find the f inverse. In this case, as x cannot be 0, right? So that is the domain of fx. Domain of f also equals to range of f inverse. Range of f equals to domain of f inverse. Okay, when you sketch the graph, okay, this is what I mean. You cannot pass that line for that function fx. X cannot be 3. Okay, so this is a reciprocal function, kan? So this is the graph, right? usually there will be two parts, but since we just consider x greater than 3, then this is the graph lah. All right, and then we sketch the line of y equals to x. Okay, all right, since this is a reflection, so meaning that that line also will be reflect across y equals to x, so meaning that you cannot have a line that passing through that y equals to x as well for your f inverse. Okay, so you have this, right? Very easy, can? So this is your f inverse. Okay, okay, how about this one? Find the inverse of fx, x plus 4, x minus 1 for x greater than or equals to 3 over 2. Alright, so usually for a quadratic function, because a quadratic function, if they didn't restrict the domain, uh, it will not have an inverse, because if we test with a horizontal line test, there will be 2 points of intersection. Okay, what I mean here, all right, if you see here, they restrict the domain here for only one side. Okay, then only the inverse will exist, because the function is already one-to-one function. All right, okay, this question is asking you to sketch the f and the f inverse. All right, okay, first we expand the function, and then by using completing the square. Okay, because once you change into completing the square, it's very easy to directly get the uh, imagination of your graph, because from x squared plus 3x minus 4, you just know the value of AA is equals to 1, 1 is greater than 0, so your graph will be smiling, but you don't know where is the minimum point. Smiling will contribute to a minimum point, right? So if you change to completing the square form, so this form you can see directly its minimum point, which is negative 3 over 2, negative 25 over 4, the coordinate. Okay, all right, so this one, why they do this calculation here. Let's look at here. Okay, they want to find their punya inverse, right? So you can start here. Okay, this is your fx, can? So you use the formula. So you just let f inverse x equals to y, then fy equals to x, also can. If you want to use this formula, also can. Fy equals to x. So now you have y plus 3 over 2 square minus 25 over 4 equals to x. Okay, so y plus 3 over 2 square equals to x plus 25 over 4. If you're confused with this solution, you just follow the one that I write here. All right, and then here you will have y equals to square, we put square root both sides, so here will be plus minus x plus 25 over 4, and we bring that 3 over 2 to right hand side, it will become negative like that. Okay, so now this is your f inverse. Okay, sama kan? This one is equal, but then since how we choose, because you have to answer here plus minus sign, you have plus minus sign here, so how we choose, you look at the domain. So since this is greater than, so we will choose plus. Okay, positive sign. Okay, taking positive sign because x greater than or equals to negative 3 over 2. If less than or equals to negative 3 over 2, then you choose the negative one. Okay, how they sketch the graph. Okay, so this is the graph of your fx. Okay, and then you sketch the line of y equals to x. All right, and now that is the graph. Okay, usually if you have a coordinate, you will have a coordinate here minimum. minimum coordinate will be here, which is negative 3 over 2, negative 25 over 4. Okay, so reflection, okay, you can find here somewhere here, okay, that is the reflection. Negative 24 5 over 4, it will be the other way around. You will have negative 25 over 4, negative 3 over 2. Okay, that's the coordinate. Okay, the point here also will be reflect to here. Okay, very easy, and they will touch at the same point here. Okay, but this one you don't have to write lah, yang the line I sketch here, the arrow here, no need. You just sketch your F, this line, and your F inverse. You have to label. Okay, please label your graph. Okay, let's look at the next example. Given that fx equals to x minus 2, x minus 9 square, x is real number, but then they restrict the domain x greater than or equals to 9. Okay, if they didn't mention this, meaning that this will be having no inverse because it is no longer one-to-one function. So that's why they put this restriction x is always greater than or equals to 9. Okay, find the inverse. Sketch the sketch the graph and find the domain. Okay. All right. In this case, they also can use the formula. Right, f negative 1x. It depends on you. You can use the formula that you learned in during your form 4 and form 5. Okay, we take the positive sign because this the x greater than just now, okay? So this is the f inverse set of x plus 9. Okay, then we sketch the graph. So this is your f, this is your y equals to x. So this is your f inverse, right? Domain of f inverse will be, domain of f inverse is range of f. Okay, so basically for domain of the inverse, domain and range of the inverse, you can get from the domain and range of your f function. Okay. Okay, number 5, the function g is defined as gx x plus 1 square minus 2 x x is real number. Explain why g has no inverse. Why they didn't have no why g has no inverse. Explain why. Okay, so you can explain by using horizontal line test. Okay, so since there are 2 points of intersection, meaning that gx is not one-to-one function. Okay, so if not one-to-one function, so we can say that g has no inverse. Alright, and then the next question just now, if the domain of g is x, but then they restrict to x greater than or equals to 0, you see they change the domain into x greater than or equals to 0. So now it will become a one-to-one function, and definitely it has a inverse, right? See here. Okay, let y equals to x plus 1 square minus 2, y plus 2 equals to x plus 1 square, x plus 1 plus minus set y plus 2. Then g inverse is equals to y plus 2 minus 1. Let y equals to x, then the g inverse will be x plus 2 minus 1. Just change y into x, right? Okay, this is the graph of the first one just now, kan, when the x is all real number, we consider all the domain on the x-axis. But then when they restrict to x greater than or equals to 0, then we remove this side. Okay, this side, we remove this side, so we just consider the one on the right hand side. Okay, so since the domain exists, so now g is one-to-one function, so g inverse will exist. Okay, and then we sketch the graph. Okay, don't forget to sketch y equals to x, then the reflection across y equals to x, so that is your G inverse. So make sure when you sketch in the exam or when you're doing exercise, so please make sure that your x and y scale to uh, equal. I mean, if you measure the length of one unit is 1 cm, then y axis also you do like that, so easy for you, so you can see easily. All right, make it the same. uh, okay, I think that's all for inverse function. So I will do the please watch the second video on logarithm function later on. Okay, see you.